Okay, here we are, lesson 10-2. We're talking about the multiplication property of square roots. And what does that mean? That means if you have the square root of a number a that's positive, a non-zero, times the square root of a number b, you can rewrite them. Sorry, the focus is doing that. Okay, you can rewrite that as the square root of a times b, and vice versa. Okay, so if you're multiplying square roots, you can put them all together under one radical sign. So we're going to see this in action a lot moving forward. That's it. So a quick example, if you have the square root of 3 times the square root of 5, you could rewrite that as the square root of 15. So this is good for building roots and also breaking them back down. Okay, if you want to take this time to calculate those really quick and see if they're the same, go ahead, push pause. I'll be here for a while. Okay, so not only can you combine multiplications, but you can also break down division. So here's the division property of square roots. If you would take a square root of a and divide by the square root of b, that's going to equal a massive square root of a divided by b. Okay. Again, if you want to plug some numbers in here really quick, if you have the square root of 20 divided by the square root of 2, that's going to be the square root of 20 divided by 2, which would be the square root of 10. So if you want to, because 20 divided by 2 is 10. So if you want to do some calculations really quick, that should all be equal. That's about it, okay? So those are the two properties we're working with. Mainly we'll be working with this one, but this will come up and sneak up on us every once in a while. So I'm going to jump right into the next one. So we're going to be using this idea to simplify square roots. Okay, not just putting them in your calculator, but actually simplifying them. So what do? Well, we want to look for the perfect square numbers. Okay, so 4, 9, 16, 25, 36, 49, and so on. Okay, why? Why do we want to look for these? Because they're perfect square roots. The square root of 4 turns into an actual number 2. The square root of 9 turns into a 3. Square root of 16 turns into 4, so on and so forth. All right. So these are the perfect squares. These are the numbers that when you square root them turn into an actual number. Square root of 60 does not do that. Okay. If I take the square root of 60 right here, it is not going to be very pretty. Okay, ew, gross. That's not the answer. That's just calculating. Okay, that's not simplifying. That's not rewriting. So let's rewrite the square root of 60. Right away, if I'm trying to look for these numbers, okay, you want to look for these numbers. If you can't break them down mentally, mathily, then you can make a factor tree. But for 160, it's quite obvious that 16 goes into it. Okay, so what I'm going to do is I'm going to rewrite it as 16 times 10. Okay, so let's see if the calculator backs me up there. Square root 16 times 10. Nope, look at that. Still the same number. I just rewrote it. Again, all I'm doing is I'm using this property right here. I'm breaking down the number into two pieces. Okay, so I guess I could even add one more piece to this. I kind of skipped a step. I could rewrite it as the square root of 3 times 5. Okay, so I should have gone here to there. But hey, whatever. I can take 3 times 5 in my head. Okay, so the next move, I don't really do this a whole lot, but you can actually physically split it. So you could rewrite it as the square root of 16 times square root of 10. Okay, and then, hey, look, there's one of those perfect numbers. We looked for it, we found it. Square root of 16 is actually 4. Square root of 10 is not perfect. Okay, even if you try to break that down as the square root of 2 times 5, okay, and break that down even more, 2 and 5 are not on the list, and they're not a pair. Okay, there's another method where you look for a pair of numbers. The idea is if you have two numbers on the inside, they can pair together and they can get out of the radical sign. So like from here, I could write this as 4 times 4. Okay, and then if you have two 4s inside the radical sign, that means you actually get a normal 4 out of the radical sign. So either a square or a pair can get you out of the radical sign. You'll see more of those if you watch the other demo videos. Okay, so since the square root of 10 cannot be simplified, okay, it's a non-simplifiable radical, that's it. That's the best I can do. Okay, so let's prove it here. So I kind of skipped this rewrite step. I go right to this. So I kind of in my mind split it and simplify it. So let's go 4 square roots of 10. Okay, same number. Okay, so what do you mean by that pair idea? I don't get what you mean by the pair idea, Mr. K. Here's what I mean by the pair idea. So I could go from this point right here, 16 times 10, 4 times 4 times 10. Same thing, okay? So the pair of 4s can get out of the radical sign. Either a pair or a square are going to get you out of the radical sign. That's the only way you can make a real number. Okay, that's about it. So most of these are on the other page. okay? And then IXL EE.1 is going to be all over this. So if you flip the page here really quick, okay, these things are everywhere, okay? So what I would like you to do is take your time, work your way through this one, and if you have this all done, then you can use this on any quiz or test in this lesson, okay? So some of them are kind of easy to figure out. So right there, square root of 5, well, square root of 25, you can rewrite it as 5 times 5, but it's also on the list. So again, 2 of them is going to make, 2 of them is going to make a regular 5. Okay, so there's the perfect square. 16 can be rewritten as 4 times 4, but it's just 4, okay? If I pick a random one on here, eeny, meeny, miny, let's go 56, okay? 56, I think I could rewrite that as, I think a 4 goes into that. Let's see, 56 divided by 4 is 14. Here we go. So I could rewrite this as 4 times 14, okay? I could go a little further. That's 2 and 7. That's not, neither of those dudes are perfect squares. So if the square root of 4 becomes 2, and then the 14 has got to stay 14. Okay, so there's a freebie right there. All right, let's double check here. Square root of 56, okay, is about that decimal. 2 square roots of 14. Hey, look at that, same thing, okay? So again, you want to hunt for the perfect squares, and if you're not a perfect square, then you have to stay inside the radical sign, okay? Sorry, this is kind of a longer video, but that's about it, friends, okay, for removing perfect squares.